Okay, well, I'm trying to do a screen capture recording here, and see how it goes. It could be a bit rough, but hopefully it will be helpful to you. So, we'll see how we go. Alright, so the first one, this is the mental section solutions, and I'm going to do these live. So, let's get a text box and call this solutions. Now, need a text box here. Okay, and let's make it deep enough to do the answer. Right, 59 plus 46. Well, 59 plus 40 is going to be equal to 59 plus 40, sorry, is going to be equal to 99. That's the first part. Now, this isn't very mathematically correct in terms of the setting out, but I'm just trying to accommodate both the voice and the video recording here. I will get better as I go along. Then you've got to add the extra 6, so altogether it's going to be equal to 105. Okay, the next one. I need to add another text box, and I'm going to be right, come here. Whoop. Yeah, it does this to me. Okay. Come down here, that's the boy. Alright, now. That. Okay, now, with these kind of problems, when you've got more than one mathematical operation, the plus is a mathematical operation, the addition is a mathematical operation, and the times is a mathematical operation as well. So we have to do according to our rule of order, we have to do the multiplication first. So it would be 3 plus 7 times 2 is 14. And then the second step would be to do the addition, 17. Okay, now this one and the next one need a text box. Alright, it's going to behave itself this time. Nice. Didn't. Okay, I'm going to get better at this as I go along. Alright, now we have to do the brackets first. So it would be 5. Now, according to our rule of order, we do brackets, then we do indices, then we do multiplication, division, then we do addition and subtraction. So we do the brackets first, so it's 5 plus the 3 plus the 7 is 10 times the 2. Now, next we do the multiplication. So I do 5 plus 20. And lastly, we do the addition. So we end up with 25. Now, if I make a mistake as I'm going along here, because I'm concentrating on all sorts of things, not just the simple mathematics, please bear with me. Okay, get another text box. And like in class, if I make a mistake, then that's a good thing. Alright, so simple now. These are collecting like terms, so we've got 15p and 5p. Now they're like terms because you've just got the 1p in the term there. And it's 15p minus 5p, which is simply 10p. Nothing fancy about that. Okay, now another text box. So this one behaves itself. They don't always behave at the moment. I'm not quite sure. Okay, so we've got an A, a Y, and another A. So we can work with the A's. We can add 6A to 10A, which gives us 16A. But we can't do anything with the other Y because it's an unlike term, so we're left with minus 5Y there. Okay. Now, alright, now what have we got here? On this one, we've got xy's, x's, and y's. Now the xy's, or the xy's and yx, because it's a multiplication, you can turn them around. Commutative is the property, if you're interested. So x and y and x are the same in multiplication, so we can work with those. So 7xy minus 11yx, or xy. So 7 minus 11, 7 to 0 is 7, and then you've got 4 left over, so it's negative 4xy. And then the other two, the x and the single x and the single y there in that expression, are unlike terms, so you can't do anything with those. 9x minus 7y. Okay, now another text box, and let's see. Okay, now this fella, it's interesting. Text. Okay, now this fella, let's get rid of that. Okay, now the g squared, because that's g times g, they're like terms, g squared and g squared. But the g, which is just g, it's not g times g, is unlike. So we can work with the g squareds. So 8g squared plus 2g squared is 10g squared. 10g. Now I'm going to have to use this caret symbol. Now that when you see that, that means to the power of 2, and I can't. I don't have the sophistication in this program to do anything more elegant than that, so I'm afraid you just have to wear that there. Alright, now the minus 6g is on its own, the negative 6g is on its own, so we're just left with minus 6g. Alright, and text box. Okay. Alright, now what have we got? We've got c to the power of 3, we've got 4 on its own, we've got c to the power of 3 again, and we've got 6 on its own. So we can work with the c to the powers of 3. So we've got negative c to the power of 3 minus c to the power of 3, so we end up with negative 8c, and there's the to the power of 3 symbol again. Not elegant, but that's the best I can do with this program. Now we've got minus 4, and negative 4 and positive 6, so that's going to give us positive 2. Now numbers on their own are of course like terms. Alright, now going down to the last question on this page, the text box, and just writing in the prime numbers. Now remember, 1 is not a prime number because it only has one factor, 1. So 2 is your first prime factor, 3 is prime number, sorry. Then 5 is the next prime number, 7 is the next prime number, 9 is not prime. It's odd, yes, so you've got what looks like a bit of an odd pattern forming here, 3, 5 and 7, but we're not talking about odd numbers, we're talking about prime numbers, so 9 is not it. 11 is the next prime number, then 13, and again you're tempted to do the odd thing and think, oh, it must be 15. It's not. 15 is also 5 times 3, so it's not 15. 17 is the next prime number, and 19 is the prime number after that. Now there's a bit of a trap there that you've got to watch, and that's that this sequence looks like the sequence of odd numbers, but as I've said to you, it is not. Okay, that's the first page, and I'll stop this and